In this video, we're going to make use of symmetry to save us time when sketching polar graphs. So we're going to try and sketch this graph here. And remember, we've seen these before. When this is satisfied, then it's symmetrical along the polar axis. Whenever this is satisfied, then it's symmetrical along the pole. And whenever this is satisfied, then it's symmetrical along the y-axis. So we've seen these before. So now, as it turns out, this thing here is symmetrical along the polar axis or along the x-axis, because if you look at this here, currently you can imagine this as this. So this thing here is really f of theta. So this thing here is this, and this thing here is this. So you can imagine this as a function of theta. Now, if you look at this, the function of theta, the negative version, if you apply this transformation and if it equals the original, then you can say it's symmetric along the polar axis. So if you look at this, now apply the negative version into here. So currently, if you look at this here, currently we've got this. Currently we've got f of theta equals 1 plus cos theta. Now apply the negative version. So now apply the negative version. It will look like this. Apply the negative version. It will look like this. Cos minus theta. Now if you look at the cosine graph, it looks something like this. Let's say this angle here is theta. So it would be somewhere around here. Now if you input a negative version, it would jump to the same height. Meaning that this thing here is the same as this. So even though we put a negative theta into here, this whole thing here is the same as the original. So we can say when we apply this transformation, it is the same as the original, because you can see it here. This cos negative theta, this thing here will equal 1 plus cos theta. So this thing here is the same. So what it's saying is that once you've applied this transformation, it equals the original. So we can conclude that it's symmetrical along the x-axis. So now that we know it's symmetrical along the x-axis, we just need to sketch from 0 to pi, and then once we've got whatever graph it may be, then we can just reflect it. It will be the mirror image of this thing here. Okay, but by right we should check these as well. But take my word for it that it's not the case here. It's just symmetrical along the x-axis. Okay, so by right you should check these as well. But take my word for it, it's only symmetrical along the x-axis. So now that we know it's symmetrical along the x-axis, we can just, now that we know it's symmetrical along the x-axis, we just need to sketch from 0 all the way to pi. From 0 all the way to pi. It's pointless going all the way around here because we know it's symmetrical. So we only need to sketch half of the graph, and then later we can flip it. So now we've got the radius equals this thing here as theta is moving about. So let's try and do this. And so when theta, we are ultimately trying to draw the polar graph. But in order for us to draw this polar graph, we need to draw this. We need to keep track of the radius. We need to keep track of the radius. So we need to sketch this graph first before we can sketch the polar graph. So now we're going to try and draw this graph here, and then we can sketch a polar graph. So the radius when theta equals 0. So put 0 into here. Cos of 0 is 1. So this thing here will be 1 plus 1, so that would be 2. So that would be right here. And then let's try and do this one. Cos of hang on. So this here is 2 pi. This here is pi. This here is half pi. So half pi will be 0. So this thing here will be 0 plus 1. That will be 1. So when theta is pi over 2, the radius will be 1. Now, when the when theta is pi, cos theta would be -1, and then you've got to plus this. The radius would be 0, and then when theta equals pi over 4, when theta equals pi over 4, try to remember this famous triangle here, 1, 1, and then this must be root 2. So cos this is like 45 degrees because this is pi cut into 4. This thing here is like 45 degrees. So this thing here is like 45 degrees, which is 4 pi. So cos pi over 4 will be 1 over root 2. 1 over root 2 will be somewhere around here. And then this 3 pi over 4. 3 pi over 4, well, now let me just clear this up. 3 pi over 4 will be something like this. So you've got your circle like this. This here is 45 degrees. This is 45 degrees. Well, you've got 1, 2, 3. So that's 3 pi over 4. Well, this thing here is from here to here. Okay, and if this is if this here is if this is 1 over root 2 in the x direction, then 3 pi over 4 will be the negative version of this thing. So it will be -1 over root 2. So the height here will be 1 take away of 1 over root 2. So it would be somewhere around here. Think about it. I've explained it badly, but just think about it. So your graph here will your radius here will look something like this. So now that we've got the radius as theta is varying, we can then sketch a graph. So we've got this graph at the moment. Currently we are here at the moment. We can now make use of this to draw our polar graph. So let's make use of this to draw a polar graph. So remember, theta is moving about from 0 all the way to pi, and we need to know the radius each step of the way. So when theta is 0, so when theta is 0, the radius. So when theta is 0, the radius would be 2. So when theta is 0, the radius would be 2. So when theta is 0, the radius will be 2. So it would be right here. And then looking at this, when theta is pi over 2, then the radius will be 1. So when theta is pi over 2, so pi over 2 would be from here to here. So that would be somewhere along here. The radius will be 1. So it would be here. Okay, when theta is pi over 4, which is like 45 degrees, the radius is more than, so this is 1.5 here, it's more than 1.5. So when theta is pi over 4, the radius is somewhere around here. So when theta is pi over 4, which is somewhere along here, the radius should be more than, well, it should be somewhere around here. So it would be, hang on, let me just clear this. It would be somewhere along here, because the radius is like that. Yeah, so it should be more than 1.5. So I'm going to guess somewhere around here. And then looking at this, when the radius is 3 pi over 4. Sorry, when theta is 3 pi over 4, the radius is somewhere around here, less than a half. So when theta is 3 pi over 4, the radius is less than a half. We're going to guess somewhere around here. Okay, and then when theta is pi, the radius will be 0. So when theta is pi, so when theta is pi, so it's somewhere along here, the radius would be 0, so it would be right here. So your polar graph will look something like this. It looks like a spiral going towards the center. Okay, and then now because we know it's symmetrical, so we can guess it will look something like this, badly drawn. Okay, so it looks something like badly drawn, but if you get a graph plotter, it will look something like this. Okay.